Hello everyone, my name's Peter Shields and on behalf of AirMet Scientific, I'm pleased to welcome you all to today's webinar, Detecting and Neutralising Hexavalent Chromium with HexChecks. We're fortunate to have Jonathon McDaniels, the Chief Scientist from Figure Engineering, to present today, and it's 9 p.m. his time in Virginia, so thanks very much, Jonathon, for presenting so late. We're excited about the new HexChecks range and look forward to hearing more about it today. So I'll now hand over to Jonathon for today's HexChecks presentation. Thanks, Jonathon.
Thank you, Peter. So to introduce myself, my name is Jonathon McDaniels, and I'm the Chief Scientist at Figure Engineering. A little background, I have 20 years of experience in metal finishing, aerospace, and maintenance industries. I've created a number of technologies related to the detection, monitoring, and mitigation of hexavalent chromium, in particular the HexChecks test swabs and neutralizer, which I'm going to talk to you about today. So a brief layout of our agenda for today's webinar. We'll begin with some background about hexavalent chromium, where it's encountered, its health effects, brief discussion on the regulations surrounding hexavalent chromium, particularly with regards to surface contamination, currently available sampling and analytic methods. I'll give you an introduction to our HexChecks test swab and neutralizer products. I'll give you a demo and then answer your questions. My main goal for this webinar is really to give you a good understanding of the challenges with surface contamination and the spread of hexavalent chromium through a facility or a job site, and the role HexChecks can play when integrated into your industrial hygiene plan and housekeeping protocols. So a little bit about Figure Engineering. Figure Engineering is headquartered just outside of Washington, D.C., with satellite locations around Air Force bases where we do significant amount of work. We were founded in 2007 with a mission to develop advanced manufacturing tools and processes. We seek to develop engineered solutions to health and safety challenges, but also provide support related to administrative and PPE controls. We've had a great deal of success working with the U.S. Department of Defense, particularly in the areas related to hexavalent chromium, as they've been focused over the past decade on finding alternatives, establishing good mitigation and control methods. We have a number of developed technologies that are fielded at DoD and private commercial facilities in the U.S., including smart adaptive ventilation systems, which actively adjust to help workers stay below permissible exposure limits for airborne hazards, hazardous material sensing and tracking technologies for use in workshops and job sites, mitigation methods such as treatment solutions, design and evaluation services, and setup of effective decon and transition areas to reduce the spread of hazards around the job sites. Getting into the presentation, what is hexavalent chrome? Well, hexavalent chromium is the toxic oxidation state of chromium. It's difficult to detect. It's odorless and tasteless, so if you've got it on your hands, you may not know. Over the long term, it can cause contact dermatitis, skin ulcers, respiratory irritation, but really most importantly, it's a known carcinogen and a pretty nasty one at that. It causes multiple types of cancer, lung, nasal cancer. We've seen people with kidney cancer. CDC did some reports where they talk about the likelihood of different known carcinogens causing cancer, and hexavalent chromium is almost 8x more likely to cause cancer than asbestos. So it's a pretty nasty one. Places where hexavalent chromium is found. Hexavalent chromium is particularly good at preventing corrosion. So you're going to encounter it in many areas where equipment is subjected to highly corrosive environments. So your marine coatings, aerospace coatings, drilling, your oil and gas industry pipelines, chromium metal coatings with engineered properties typically use hexavalent chromium baths. Anodized sealants, in some cases, are done using boiling chromic acid. Other areas you're likely to see it, welding and cutting of chromium alloys and stainless steels can generate hexavalent chrome fumes. Paints and pigments, so textile industry. Chromated copper arsenate in the timber industry is used for a long time as a preservative. So you're likely to encounter this in demolition processes or in construction debris. It's found in many cements as a byproduct. So it will result in cases of contact dermatitis or what they call cement eczema in exposed workers. In addition, it also occurs in areas you might not expect. We recently met with some turbine companies in the US who were finding hexavalent chromium in their equipment during routine maintenance operations. And they weren't sure how it was occurring because nothing in the manufacturing process contained hexavalent chromium. Turns out there's a reaction occurring between the lubricants and the anti-seize and the steel alloys in these pieces of equipment when they're exposed to high operating temperatures, and it creates hexavalent chromium. So they were looking for a solution. Here's an example just to show you just how widespread and extensive the use of hexavalent chromium in an industry like aerospace is. This helicopter uses hexavalent chromium plating or has chromated coatings on everything from engine components, landing gears. It's the primer covering the entire surface. There's hard chrome on the underside to prevent foreign object damage. And there's been a big push over the past decade to reduce the use of HexChrome and find alternatives to HexChrome on many airframes, including this one. The big issue here is that while these newer aircraft might have reduced levels of HexChrome, assets currently in service will eventually come in for maintenance, and they'll still have these coatings on there, exposing workers to these hazards years later. And many of these hazards will be on the aircraft for the lifetime of the aircraft. An example we've seen with dealing with some aerospace maintenance clients who do strip and repaint is that the chromated primer is so good at its job that they will attempt to preserve the primer by just removing the top coat of paint, leaving the HexChrome primer in place, and then recoating. They've seen that the performance of, at least currently, the performance of these hexavalent chromium primers is just so much better than a trivalent or a non-chromated primer that they will seek to leave it in place. So that plane is going to get sent back out into service with the HexChrome primer and will eventually come back to the depot for maintenance, and it will still be a worker hazard. Briefly discussing some relevant HexChrome regulations. Most of our experience is working within the US-based OSHA regulations. A lot of that is what's driving the DoD and aerospace industry to rein in HexChrome usage and find ways to continue using HexChrome in safe ways. So OSHA has set permissible exposure limits for airborne at 5 micrograms per cubic meter. But for surface contamination, they use what's known as clean as practicable approach. So this can create confusion for industrial hygiene personnel, as the interpretation for what is clean as practicable can vary and potentially leave people exposed to lawsuits or citations. In the EU, particularly looking at the reduction of hazardous substances legislation, HexChrome is classified as a substance of very high concern, and they severely limit its use. So we've had customers in Europe specifically interested in our testing solutions as a way to handle RoHS and REACH regulations. They're finding HexChrome on imported parts. They need a quick way to evaluate suppliers for compliance before they accept parts. For you all in Australia, your WHS regulations use similar clean as practical standards, requiring companies to reduce exposures as far as is reasonably practicable. So how does hexavalent chromium spread around your work site? Well, you can have fumes, mist, dust spread around the facility from blasting, painting, plating operations with containment leaks or insufficient ventilations. Most spread comes from people, though. I've got some pretty gnarly examples there on the right of a chrome plating bath that was used in an aircraft maintenance facility. So you can kind of get an idea on how these mists and dust can coat these surfaces. Personnel walk over these areas, get stuck to their boots, on their gloves, they track contamination further around the job site. If you don't have good doffing areas for worker PPE, you'll often see people go into bathrooms or break rooms with PPE still on, further spreading the contamination. In the center of the slide's a heat map we created of a job site to help customer find sources and migration patterns for HexChromium in order to set up better worksite controls. So you can see the abrasive blasting booth there in the bottom of the image. That's the big red area. But you can also see a source in the top left, which was a welding operation where they had insufficient ventilation. And they actually weren't aware that that was an area of concern until they saw this heat map. So ways you can reduce spread. Once you know where the HexChrome's coming from and how it's spreading, what can you do? So controlling access and creating regulated areas is a good start. Setting up doffing areas so that personnel wear and remove PPE in source areas and make sure that it stays in the source area. That dramatically reduces spread. Routine housekeeping is very important. Dust and mist are going to get out even when the best enclosures and ventilation systems are in place, simply because you have to move parts in and out of these booths. People have to come in and out, and they have to move around the facility. So above all, good housekeeping procedures, checklists, and making sure those housekeeping procedures are followed is critical. Routine sampling is important. I'm not going to talk a lot about the airborne collection. I'm going to focus more on surface sampling. Regulated areas mandate airborne worker exposure sampling, but even if it isn't mandated for certain areas, particularly for surface contamination under the as clean as practicable approach, you should still do routine checks in areas, particularly in break rooms, bathrooms, and offices, just to monitor that your hygiene plan is working. Ways you can test for hexavalent chromium. So most laboratory methods use chromatography or colorimetry for tests of hexavalent chrome. The labs have to be very careful in the methods that are employed for sample collection, sample digestion, and handling in order to preserve the state of the sample so that any non-hexavalent chrome in the sample doesn't accidentally get converted. For airborne standards, two of the major ones are OSHA ID 215 and NIOSH method 7600. OSHA 215 and NIOSH 7600, they're very similar methods with exception of a couple of details about the testing procedure and the sampling method. NIOSH 7600 can differentiate soluble and insoluble chromates, whereas the OSHA ID 215 has a much lower detection limit. For what it's worth, when we need to do airborne exposure monitoring, we use ID 215. For surface sampling, OSHA created the W4001 standard. Again, it's very specific in the selection of white materials and handling, extraction, and test methods. All of these test methods use expensive equipment and most labs have limited turnaround time. So it can take some time from when you get a sample until you see the results. Lab samples also come at a high cost. I think right now, one of the labs we work with is charging about $80 US per white sample. So as you can imagine, it's going to add up pretty quickly if you want to keep a frequent eye on a lot of different areas. So I want to introduce you to HexChecks. HexChecks can help your organization overcome many of the challenges I just mentioned. HexChecks are a small pen-type swab with crushable ampules inside. They're packaged in small boxes of 10. Got one here in front of me. You can fit it in your pocket, can easily be taken out, used for spot checking. You can walk around the job site with it. You're not encumbered. They turn a very bright purple when hexavalent chromium is encountered. So HexChecks are very simple to use. You pull a swab out of the box, crush the ampules, shake it, rub it on the surface you want to test. The color change will start developing instantly if hexavalent chromium is present. It'll take about 3 minutes for full color development, especially for the really low levels. Excuse me. This gives you a very clear indication of the presence or lack of presence of hex-chrome. The darker the color, the higher the level of hex-chrome is present. They're priced to allow freedom to use them for routine monitoring and spot checking in many areas. It's far less. You can run a lot of these for the cost of a typical laboratory swipe sample analysis. So it really frees you up to test those areas where you just want to check to make sure your housekeeping plan's working. You want to see, does this area have an issue? You can use a hex check, and you're not gonna go bankrupt doing it. You can use these to monitor break rooms, bathrooms, high contact points such as door handles, keyboards. Make sure your housekeeping and regulated area plans are working. So I'm going to do a video demo of HexCheck swabs, and I'll talk you through it. So crush, shake, wipe. Surface in question, if there's hex-chrome there, it's going to turn purple, and there it is. So it turns a bright purple. Simple. So I want to talk a little bit about the validation we've done on these. Independent validation was performed by the United States Air Force School of Aerospace Medicine. This was developed and tested at the request of multiple Air Force bases looking for a rapid hexavalent chrome test. The full validation was performed by USAF SAM, who has approved and recommended them for Air Force adoption. They reliably detect below 0.1 micrograms of surface contamination. USAF SAM testing indicated color changes at 0.01 micrograms with reliable darkening as the concentration of hexavalent chromium increased. So along with USAF SAM, we've run specificity and interference testing on the swabs. Results indicate high specificity to hexavalent chrome. Other forms of chromium, such as trivalent chrome, do not interfere. We've tested interferences against commonly encountered contaminants in a workshop environment and found no interferences. We've also performed field testing at Air Force Base workshops and found no interferences. With regards to shelf life, all the ingredients are sealed in ampules and packaged under argon. We've done accelerated life cycle testing, and at this time we have an indefinite shelf life because they are packed under argon. Anecdotally, we've been producing these swabs for about 2 years now, and I still have some from the initial production run, and they've shown no degradation. At an oil and gas customer's request, we ran high temperature exposure testing. They wanted to see if the swabs could sit around in a truck dash in a hot environment. So we tested, excuse me, we tested 8 hours at 95C. Saw no degradation in performance. So this is kind of giving you, like, you're out in the desert, you have these sitting on a truck shelf, truck dash. Are they still going to work for you? We saw no issues with that. I wouldn't recommend long-term storage there, but short-term, you're taking them out on the job site to work, they're going to work just fine for you. As far as actual temperatures of use, essentially you're bound to temperatures where the liquid in the swab actually stays. a liquid, so about -5C to 70C. Moving on, talking about HexCheck Neutraliser. So now that you know you have an issue, you've tested for it, how do you get rid of it? That's why we created HexCheck Neutraliser. It pairs with our HexCheck test swab product as a way to eliminate the hazard once you found it. Rapidly converts hexavalent chromium into the trivalent form. It's very simple to use. Comes packaged in little sachets that you see there on the right. One sachet makes 1 liter of neutralizer. You simply empty the contents into the spray bottle, fill it with water, shake it up, and you're good to go. It contains no hazardous ingredients, no harmful solvents, and is safe for use on almost all surfaces, including clothing and skin. A little bit about third-party testing of it. We used SGS Galson as a third-party test lab to validate the performance of the neutralizer. Samples were created using chromated primer dust. We tested against control with distilled water. So samples were placed on filter paper, sprayed with neutralizer or water, sent to Galson for OSHA W4001 analysis. Results show almost total elimination of hexavalent chromium from the sample. And that data is backed up by in-house testing via demonstrations using HexCheck's testing swabs, as well as testing we've performed at Air Force bases. So I'm going to show you a demo of the neutralizer. So again, it starts with the swab, check the area, see if there's hex-chrome present. Purple, hex-chrome is present, so now you're going to treat it. Simple spray with the neutralizer, wipe with a wipe. Retest with a fresh HexCheck. No hexavalent chromium is present. And it doesn't show in this video, but you can also check the wipe that you just wiped away. So in case you're thinking that you just wiped it away and you just threw away the wipe and that's got the hex-chrome on it, that also, when you test the wipe, shows no hexavalent chromium is present. So with that, I'll open the floor for a question and answer session.
Thanks, Jonathan. We've already got a couple of questions, but if anyone has got any questions, please just type them into the questions box and we'll take them one at a time. So first question, Jonathan, is could HexCheck detect on clothing before sending PPE to a laundry?
Yes, it can, and we have checked it on PPE, blast suits, gloves, things that you might want to send to a launderer. It will detect on those.
Thanks, Jonathan. And the next question says, has the validation and reliability of the darkness of the result confirming the level of chromium been reviewed by SafeWork Australia? I can start by answering that and say no, because this is just a new product in Australia, but Jonathan might want to add something about the testing that's been done, the validation that's been done.
Yeah, so like I discussed, the validation we've had done has been done by the U.S. School of Aerospace Medicine. We would be happy to have it subjected to other organizations testing, including SafeWork Australia.
Yeah, thanks, Jonathan. And I've seen that report, and I'm I think it's probably okay to share it. I'll have to confirm that with Jonathan first. But then next question. Thanks for the presentation. Is there a minimum surface area to be swabbed to achieve the limit of detection?
No, again, it's sensitive to 0.01 micrograms. So it really, if you want to do quantitative, you would do a given surface area. So say like for like the NIOSH wipe samples, it's a 100 square centimeter area. That's not necessarily required for HexChecks. It's really an indication of the presence of hexavalent chromium. So things that may be difficult to get a known surface area on, such as like a keyboard or something, or a door handle, you can wipe it on there. It doesn't have a minimum. It's going to trigger as soon as it gets to that minimum amount of 0.01 micrograms, whether that's on a square centimeter or on a 100 square centimeters. It's going to trigger.
Thanks for that. Next question: are there any surface types you wouldn't recommend using this product on?
None that I can think of right now. We've tested on a lot of different surfaces. Not that I can think of. I mean, maybe something like paper or something, because you're not gonna be able to wipe something. You couldn't wipe the solution away easily. But you know, we haven't seen anything that it's been a real problem on.
Great. That looks like all of the questions. And to everyone in the audience, thanks for attending today. I'm sure you found it very informative and interesting. Thanks, Jonathan, for your time today. We really appreciate you accommodating our time difference by presenting late at night. Extremely interesting presentation and some great solutions for detecting and neutralising hexavalent chromium. So thanks very much for your presentation.
Yeah, I'm always happy.